Okay, so now is where things start to change. Okay? So remember, Dalton made a postulate that every atom inside of an element is exactly the same, all the properties and everything. Well, that, we find out, not so much true. We have something called isotopes. Isotopes are atoms of the same element that have a different mass number. Okay? Now, where exactly does the mass of an atom come from? Your nucleus. What is your nucleus made up of? Protons and neutrons. Now, in order for your atoms to stay the same, what is the only thing that can change? Your neutrons. If you have more neutrons, your atoms remains the same, but your mass is going to be different. Okay? Here you have the isotopes of hydrogen. You have protium, you have deuterium, and you have tritium. Protium has 0 neutrons, 1 proton, 1 electron. Deuterium has 1 proton, 1 electron, 1 neutron. Tritium, 1 proton, 1 electron, and 2 neutrons. Okay? These are what these things ultimately look like. Okay? So what's happening? Tritium, for tritium we use that in a biolab. Tritium is radioactive. Okay? The half-life, meaning how long it takes for half of your tritium to go away, is about 37 years. Okay? So, dangerous stuff. Right? Deuterium, we use that as a labeling for certain chemical reactions. Alright? So again, isotopes are simply atoms of the same element that have different number of neutrons. Here, how do we write our isotope symbols? In order to write our isotope symbols, we need to understand certain things on the periodic table. This is ultimately what one thing on the periodic table looks like. One element on the periodic table looks like. You have this one number, this is called your atomic number. Your atomic number is 9 times out of 10, the number up top. And it's always a whole number. Alright? You have the elemental symbol. You have the elemental name. And then you have the bottom, which is your mass number. Alright? Now your atomic number represents the number of protons that you have in your atom. And it has a symbol Z. If your atomic number represents the number of protons that you have, what does it also represent? Electrons. The number of electrons. Why do we know that? Because they're equal, they need to be equal in order for you to have what?
Neutral charge.
A neutral charge. Very good. Right? So your mass number is equal to the sum of the number of protons and the number of neutrons that you have. It has a symbol of A. Do we get that? Alright. Now, we need to be able to distinguish between our isotopes. So, when you have your isotope, how do we write our isotope symbol? You have our element, whatever your element is. You have the symbol. Initially on the periodic table, you will always find your atomic number on the top, your mass number on the bottom. When you're writing your isotope symbols, your mass number will be on the upper left-hand side. Your atomic number will be on the lower left-hand side. Alright? Now please write for me the isotope symbol for my isotopes of hydrogen. the isotope symbols for my 3 isotopes of hydrogen.
H1, 1,
H,
H1, 1,
1, 1,
then H1, 2, and then H1, 2.
Pardon me, you said that the first is atomic mass. What top?
for the isotope symbol, what does A represent?
The mass.
The mass. What does Z represent?
Protons or electrons.
The
Atomic
number.
number.
Atomic number.
The atomic number. You just told me protons and electrons. Is that so?
It's only proton.
And neutron.
No.
Oh, it's neutron.
The right conjunction is what I'm looking for. You know, conjunction, junction. What's your function? What does and mean?
It's
It has to be
number.
No.
Add.
Add. And means add. Is the atomic number the sum of protons and electrons? What is it?
So it's the number
Some
of
protons.
No. Tell me.
The mass number.
The mass number is the sum of your protons and your what?
Neutrons.
And your neutrons. What is your atomic number?
the number
Number
of
of
Protons or
Or
electrons. That matters. Tell me.
I just make a switch. Yeah, 1, 2 become 1.
Two.
Yeah, the two
Sure?
on the top.
Yeah.
Wait, so the atomic number is what again?
Your atomic number is the number of protons or the number of electrons. So when you're writing your isotope symbols, your mass number goes on top. Your atomic number goes on the bottom. So for deuterium, what's my mass number?
1.
Oh,
Maximum 2.
put
2. It goes where? Top or bottom?
on the top.
Who goes on bottom?
One.
one.
Up here? Tritium?
3 on the top and 2 on the bottom.
2?
1.
1.
What about for sodium? Now the one thing that you guys are going to get used to is whipping out your periodic table. Your periodic table must be on you, out with you at all times, because we will be going back and forth to your periodic table. Right? So what about sodium? What's the isotope symbol for sodium? Na.
And then 23 on the top and 11 is the bottom.
23 on the top, 11 on the bottom. Are we in agreement? No? What do you have?
Yes.
There was a top.
11 on the top?
And 22.
For the isotope,
The isotope symbol. 11 on the top, 23 on the bottom.
didn't you say that
What does Z represent?
the atomic number?
The atomic number. Which is the atomic number of
11.
sodium?
11.
11. Right? So this is wrong.
Wait, what?
This
We're
is
still
wrong.
doing isotope symbol.
Isotope symbol
Yeah, then that's right.
is
That's
this.
for the Z. This is if to the left is if it's on the periodic table.
What?
To the left is if it's on the periodic table.
What is it?
That's what you just drew, crossed out.
This one right here. Oh, this would be the symbol for on the periodic table. Yes. Right?
So it's 23 on top and 11 on the bottom.
Yes.
Yeah. For the isotope.
Yes.
Oh, so it's basically just a flip,
Yes.
or, and you round it, the number that's there.
Yes.
Okay,
You want whole numbers only.
okay.
All right. So now if I give you this chart and I ask you, what was the time? What time we have?
11 on the hour.
Okay, we got tons of time. Right? So, what was I saying? I gave you the chart. You can fill in all of this information, which is a few bits of information from the periodic table. What is the easiest thing for you to find? If I give you these isotopes,
The mass.
okay? Easiest thing for you to find is the mass number because that's given to you. Right? What else can you find?
Atomic.
You can time
Number.
The atomic number. How do you find the atomic number?
Atomic mass minus
No.
number of
It's on the
protons.
chart.
Your periodic table. Your atomic number is on your periodic table.
26.
So for iron, 26. Manganese, Mn,
25.
25. Neptunium, to be all the way to the bottom.
93.
93. Carbon.
6.
That's what I got too. Now, how are we going to find the number of protons? No.
Subtract the atomic number.
No.
Number.
The number of protons.
It's the same
The same as the atomic number. Can't forget that. Right? Now, how do we find the number of neutrons?
You
The
subtract.
mass, you gotta subtract that. Number of protons.
Now you gotta subtract.
You're going to subtract what from what?
The
Atomic mass.
Your mass number, you're going to subtract your atomic number. And what do we have for iron?
28.
28. Manganese. 31. Neptunium.
144.
144. Carbon. That's what I got too. Okay?
Yeah.
Now, we can reverse it. Okay?
Yeah.
If I give you your atomic number
Same thing.
and the number of neutrons, what is the easiest thing for you to find?
The protons.
Number of protons. How do you find the number of protons?
same as the atomic.
Same as the atomic number. So that's given. What else is easier for us to find? Mass number. What would our mass number be? For the first one.
Proton subtract the
Ah!
neutron subtract the
Add
add.
Neutron plus proton.
You're going to add
Oh,
your
yeah, oh, yeah.
protons and your neutrons. So what's it for the first one?
One
133. What about your second one? 133. 210 you said?
Yes.
Third one. 130.
37.
137. 130 or 137?
130. 130. The last one is 37.
The last one is 137?
No,
Good,
37.
37. That's what I got too. Now, you can identify what my isotope symbols are. So, what's my isotope symbol? Since we got chlorine, what is it? So, chlorine, 37 where? Top, 17 on the bottom. What about the next one?
37.
That's isotope.
Oh,
Hmm? He. Xenon. What's up top? 130. What's on the bottom?
54.
Next one.
Radium. 80, sorry.
Say it again.
82.
Is lead
Lead.
What's up top?
210.
Bottom.
82.
Last one.
Cesium. Top is
133.
133.
55.
That's all I got too.
We have to like number all of the periodic table.
No, sir. Just 1 to 20.
That's it.
You have to, for me, I want you to memorize fully 1 to 20. Okay? But you need to be aware of everything on the periodic table. When we get to figuring out the trends and things of the periodic table, it'll become more familiar to you. But for right now, we'll take things slowly as they come. Tell me.
Is it always mass on the top and atomic number on the bottom?
When you're writing your isotope symbols, yes.
Yeah, because on the periodic table it's the reverse.
Right. That's on the periodic table. This is your isotope symbol, something different. Okay.
Oh, the number is 1 to 20.
Do we have periodic table on the exam?
Okay.
It says the number.
So
You want to include it?
now, understand my position on having the periodic table. Okay. The periodic table tends to be a crutch. Okay. It is. I will give you every single thing that you need to answer my questions on the exam. Your periodic table, sometimes if you feel you don't necessarily know how to answer a question, you will spend the time staring at the periodic table. Please let it come to me. What am I supposed to do? Oh my God. If this is it, what am I supposed to do? This is what happens with the periodic table. And you spend countless amount of time just staring at the periodic table, but you don't need it. Because I will give you every single thing that you need.
You're not gonna do it this opposite way where we gotta figure out the isotope.
Of course, why not?
Because then I have to memorize all the numbers and the
No, you don't. Because I will give to you. If I give
Can
you,
you give an example of what you're trying to say?
okay, bet. If I ask you to write the isotope symbol for helium, and I tell you the mass number, or I give you Z is 2, A is 4.
Yeah, not in that sense. Like just now, we have to basically look at the table to see what the symbols are. I'm saying you're not gonna.
Right, no. Like if that's the case, if it's 1 to 20, you should know it.
Okay.
Right? But if it's like 85, I'm not gonna expect you to know that. I'll give that to you.
Okay.
Right?
That's what I was saying.
Yeah. Okay. Now, isotope questions.
Wait. Oh, hold up. One more.
Yeah, go ahead.
For 1 to 20, we need to know that number at the bottom too.
No, you don't need to know the mass number.
Okay.
Just the symbols, their names, and the atomic numbers. Okay? Find the mass number, the atomic number, and write the isotope symbol for an atom that contains 7 protons and 8 neutrons.
Nitrogen.
Nitrogen.
So you write. You want me to start?
Sure, go ahead.
Okay. The symbol is N.
And
The mass number, which would go on the top A, is what's the?
no, I'm looking at the periodic table. You gotta look right here.
That's not 15.
You gotta look right here. You have to give it the number that I give to you.
Okay, 15, because it's the protons and neutrons. And then atomic number is 7. And that's the isotope symbol.
That's what I do. Did we get that? Next one. How many neutrons are there contained in an atom of nickel-60? When you see an element dash a number, that number is your mass number. Okay? So now, how many neutrons are there in nickel-60? And how you figure it out? So how you find that? Periodic table.
You said it's the mass number?
Yes.
That is 32. 32.
22?
32.
32?
Yeah.
That's what we got. Are we in consensus?
60 over 28.
60 over 28?
60 minus 100.
So I got 2. Okay. How many protons and how many neutrons are contained in an atom with a mass number of 26 and a symbol Mg? What's Mg?
And 14.
14.
12
And 14 protons, neutrons.
Neutrons? You sure?
Yeah.
That's what I got too. Okay? Oh, we're gonna act like we don't see this right here. You don't see that right now. Okay? What are the atomic numbers, mass number, and the isotope symbol of an atom that contains 4 protons and 5 neutrons?
The mass is a 9.
The mass number is going to be 9 because you have 4 protons, 5 neutrons.
Beryllium.
Beryllium, how we figure that out?
There's number 4.
Number 4, protons. So therefore our isotope symbol is Be up top, 9, bottom, 4. Good. How many neutrons are contained in an atom of chlorine 37?
20.
20?
20, yeah. 7.
Are we consensus on that?
Yes.
So I got 2. How many protons and how many neutrons are contained in an atom with a mass number of 28 and the symbol of Si for silicon?
So you have
14 and
14
14.
protons.
14 and 14.
14 and
14.
14. See, what had happened was, like my finger had slipped and hit 18. That's what happened right there. So you know we're supposed to be 14 right there. Okay? Right.
Minus 2.
So, okay, let's see. Now, relative masses. When are we dealing with, remember the size of the protons and the electrons and the neutrons? What exactly is the size of that? Is it very big or is it very small? Very small. So now instead of determining looking at the mass of an atom as itself, we're going to look at the relative masses, meaning we're going to compare how the masses are compared how they are to each other. How much difference, what's the difference between them two as compared to each other. Okay? So here, for example, we have calcium. Calcium has an atomic mass of 40.08, while neon has a mass of 20.18. What can you tell me about the relative difference between the mass of calcium and neon? Or in terms of the size? How much bigger? Twice as big. Now, when we talk about relative masses, we're talking about a ratio. What type of arithmetic do we have for a ratio?
A division.
Division. So you're ultimately going to be dividing these two. So if you divide your calcium by your neon, you're going to get the size comparisons is roughly 2. So that means calcium is twice as large as neon. You can look at also the actual masses of each individual atom. Calcium has a mass of 6.655 times 10 to the negative 23 grams. Neon has a mass of 3.315 times 10 to the negative 23 grams. If we do the ratio for this number, what's the answer there? Okay. What do we have?
What are you asking me?
If we plug this in the calculator, what is the ratio between these two numbers? I want you to plug it in. I want to see how y'all working out your calculators, how y'all plugging in scientific notations in your calculators. So remember, it's the bigger one divided by the smaller one.
It's 1.98.
1.986.
6, yeah.
Yeah.
Still the same value. Okay? So now, let's bring this home. Alright? If you had let's say, bring it home, right? Back in the day, on the playground, what is the one piece of equipment, one plaything that we want to have? Like you have to have two people to play
Seesaw.
Seesaw. Okay? What is the basis for you to have a happy seesaw experience? You must weigh the same. Okay? Now, for example, let's say this right here, this is the biggest I've been in my entire life. Okay? Imagine me at 7 years old. I look like a little lollipop. Right? So, let's say you had Skinny Mini Nika and you got Big Bertha. Okay? You have Skinny Mini Nika and Big Bertha on the seesaw. What's going to happen? I'm going to fly. I'm going to have you dangling, y'all. Okay? So now, let's say Big Bertha is twice my size. What do I need to do in order to balance out Big Bertha on this seesaw?
Get a clone.
Get a clone. I need two of me. Two of me will balance out one Big Bertha. This is how we're going to be looking at relative masses. Okay? Now, on the seesaw, how many? So what is the difference between the mass of carbon and bromine? So you have your seesaw. What is it going to look like?
Oh, they're going down right now.
Hmm?
You said it's twice as much?
No, you tell me what is it.
Calcium is gonna go flying.
Calcium is going to go flying. So you have this type of situation. Bromine, calcium. Alright? So if you look at the mass of bromine, the mass of calcium, how many calcium will balance out bromine?
2 to 1.
2. So you need 2 calciums for every 1 bromine. Do we see that? Next, how many heliums will balance out 1 oxygen atom on your seesaw?
4.
4? How we figure 4?
4 times larger.
4 times larger. Helium is 4, oxygen is 16. How many hydrogens will balance out 1 carbon? 6.
12.
12. Do we see that? Okay. Now our actual mass, yes?
So in the case where it's like beryllium to like magnesium,
What's beryllium? Beryllium is what, 9? How much?
9.
9. Magnesium is...
No, wait.
Yeah.
Yeah, the magnesium is 24.
Okay.
So you need like 2.5 beryllium.
Pretty much.
Oh, that worked.
Mhm.
Okay.
Okay, so you see now, if we go back to the actual masses of calcium and neon, the actual masses are, the units for your actual masses is in grams. Your relative masses is measured in atomic mass units. Remember, where do you find atoms? Inside of elements, right? Your relative masses has to do with your elements. So that is a compilation of all the atoms in there. This is measured in atomic mass units or U's. Okay? Your actual masses is represented by a single atom, a single atomic mass unit in which is the 12th of the mass of your carbon 12. Okay? What this means is that each of the actual mass, your single atom, carbon is the most abundant atom on the periodic table. It's abundant in nature. Everything ultimately is based off the mass of carbon. Alright? Your relative masses that's on the periodic table right now, all the masses that you see on the periodic table is on the atomic mass units. The atomic mass units is also called your atomic what is the atomic weight of calcium? And you're going to tell me 40.08 atomic mass units are used.
40.0.
08.
Which one you said?
Calcium.
So that's,
Because atomic weight
It's
and
the mass.
atomic mass is the same thing.
Yes. Alright? So now you have something called molecular weight. Your molecular, what would molecular bring to mind? A molecule. So this would be the mass of your molecule. How do we figure out a molecule? What's a molecule? The combination of two or more elements, right? So your atomic weight will be the sum of all of your atomic weights combined.
Yeah. The molecular.
Your molecular weight will be the sum of all the atomic weights in your molecule.
So it says, say like water, you have to add the atomic weights of
Yes.
H's and O's.
Yes.
Okay.
So from what Monique is saying, if you have H2O, what is the atomic weight for hydrogen?
2.
1. How many hydrogen do you have? 2. The atomic weight for oxygen? I should minus 2 from y'all.
16 grams.
No.
16 AMU.
Use.
60
Atomic mass unit.
Use. Right? So, excuse me.
Unit.
So, each of your atomic weights, your molecular weight would be the sum of this. So what is the molecular weight for water?
18 U's.
18 U's.
Why do you just say U?
you
18 units?
U's, atomic mass units. Or U's,
One
the
is
symbol is
unit.
U's.
More than one is unit.
Yeah, if you have 1 U, you can have 18 U's.
No, because I said 18 AMU and you said 18 U.
Same thing.
Oh, okay.
can you go say that one more time? What happened? I'm sorry.
So, in order to find the molecular weight is the sum of all the atomic weights in your molecule.
Which is the same as the atomic mass.
With the same as atomic mass.
Got you. And we said that. Oh, so you look at hydrogen is 1, but you have 2 hydrogens, so that's 2. And then you have 1 atomic oxygen, which is 16. Okay.
Alright, so now we have an example. Okay, we're going to calculate the molecular weight of urea. Now, I like to do this in steps. Okay? So, step 1. Step 1 is to identify each atom in your molecule. Got that? Step 2. Determine the number of each atom. So how many atoms do you have of each? Step 3. Multiply the atomic weight by step 2. Step 4. Add everybody up. You can't see, squinting. Right? Come on, let's start. Step 1, what do we do?
Identify the atoms. I'm looking up. So you have C.
Don't tell me C, we passed that.
Carbon.
Carbon.
Hydrogen. Nitrogen. Oxygen.
Step 2.
Determine the number.
1,
4.
2, 1.
3.
Multiply the atomic weight.
12. 1.
Minus 2.
12 units. 4
Three.
units.
1 unit.
14 units.
16 units. 12.
12.
U. 4 units. 28 units.
16.
16 units.
And they added 60.
16 units.
That's what I got too. I use more significant figures here. That's why I have a larger number. But again, if you round my number to 2 significant figures, where would it be?
60.
60. Do we get that?
Is that a U?
That's my U.
Oh.
You trying to judge my handwriting? I'm just saying.
That's how they
I
write
was
it,
just
though.
making sure.
Where the first set of numbers come
Which number? This here?
from?
So if you look here, you're going to count how many of each atom is present. That's step 2.